Hello, geometry. All right, so we are going to really dive into some things today. And also, I want to just show you that. So week 4, 5, and 6, 7, and 8. Here's the plan for the rest of the summer. And also, we're not using Khan Academy for the this part of the summer. We're using IXL. So I have given you in Google Classroom. Let's just go to that Google Classroom real quick. I've given you each IXL login info. So you can click on that assignment. It's someone else's account from the year because I ran out of accounts. But it's yours now. They're not using it. And so that we can complete these assignments. When you do IXL, I'm sure you guys have probably done it in the past, maybe. But so it tells you the questions answered, the time elapsed, and the SMART score. So on Monday, I want you to complete 10 minutes for each assignment. And then throughout the week, we want to get that SMART score up to 90. So I know that it goes up and down and can bother you when it goes down 12 points. But anyway, that's what we want to do. And in the middle, posting in the organizer. So you do 10 minutes each in order to get the question from each assignment that you want to put in the organizer. So for every assignment, and we have B1, 5, 6, 11, C1, 2, 3, and 4. So I should see one question in the organizer at least from each one of those. And then I'll even, the week 3 table is right here. I'll just make the little, this is the red section. This is the yellow section. And this is the green section. So you can, based on your comfort level with the assignment, you can put the problem in one of the 3, put your name in one row. And if we run out of rows, just press tab and you'll have a new row. Okay, so let's go. First thing we're going to talk about is the segment addition postulate. On Thursday in week 2, we talked a little bit about adding angles together. We'll talk about that again, but in geometry, you can also add segments together. So this is segment JL, as we talked about. I would write it like that. When you don't put the bar over the top, let me write this, segment JL. When you just write the 2 letters next to each other, this is the measure or length of segment JL. So see how they didn't put the bars over the top? That's on purpose. That's because they're talking about how long JK is, or the distance from J to K. So we know that J to K is 4x plus 16, and K to L is 6x. And we know J to L is 12x minus 10. So we can write the segment addition postulate, which says that J to K plus K to L is J to L. I'm going to write that down in words because you're probably like, what is segment addition postulate? And why do you keep saying that? I've never heard that in my life. All right, segment addition postulate. In geometry, we have postulates. Sometimes they're called axioms. And they're really fun words to say because people don't say postulate and axiom all the time. You sound really smart. What these are is if-then statements. You know about if-then statements. If I do my homework, then I'll do good in class. Something like that. Postulates and axioms are statements, if-then statements that people can see as obvious. All right. It should be obvious to you that the total distance is the sum of the 2 parts put together. Just a nice simple example without the x's. If from here to here is 3 inches, and from here all the way to here is 7 inches, then the total distance is 10 inches. You have to add the 2 parts together to get the whole, right? That's the segment addition postulate. It should be axiomatic to you that that happens. But if not, that's why we start there in geometry. So now, what we're going to do, since they gave us expressions, is we're going to substitute in those expressions. So JK is 4x plus 16. KL is 6x. And JL is 12x minus 10. I think they do this because they don't want you to get too rusty on your algebra. All right, so combine the like terms. 10x, 16, that's it, plus 16. 12x minus 10. Then we want to get our variables on one side and our numbers on the other. And I usually put the variables on the left, the numbers on the right. And if a term switches sides, then it has to switch sign. So the 12x is going to go over there. So that's going to make it negative 12x. 16 is going to go over there, which makes it negative 16. 10 minus 12 is negative 2. Negative 10 minus 16 is negative 26. Divide both sides by negative 2, and we get x equals 13. Just make sure they're asking you for x, because they are not in this case. So in this case, they're asking what is jk. Now, jk is 4x plus 16. All right, that was what jk is. So now we got to substitute, right? All right, so what's 4 times 13? 26, 26, 52. All right, 52 plus 16 is 62, 68. All right, so hopefully that's helpful. We'll go over the success criteria in class, but use that example, and now you try for 10 minutes. And then post your questions in the organizer in green, yellow, or red. Next up is midpoint. T is the midpoint of SU. All right, so this is the same thing, only now you can see that the point is in the middle. It's the midpoint. All right, so that means that ST and TU are equal. They're congruent. And whenever segments are congruent, we use a little hash mark. So midpoint there, I put a hash mark and a hash mark, and that means same. These are the same. All right, that's the idea. So what does that mean that we can put for ST? Well, TU is 2x. So that means that ST must also be 2x because they're the same. And now I can do my segment addition. Back to safety. We know the segment addition postulate. We know ST is 2x. We know TU is 2x. And we know SU is 3x plus 4. So then we combine our like terms. And we put our variables on the left. You know, maybe you said subtract 3x from both sides in your Algebra 1 class. That's the common way to say it. X equals 4, but we don't want to know x. We want to know TU. So let's make sure that we substitute. TU is 2x. So now it's 2 times 4, 8. The answer is 8. All right. That's B6, so try that for 10 minutes. You know, pause the video, try that for 10 minutes. Distance formula. I love the distance formula. I wrote a song for it. I'll put the link in the Google Classroom, but I don't want to go there right now. So it's find the distance, take the root of x2 minus x1 squared plus y2 minus y1 squared. Then you're done. Then you're done. So it's Frere Jacques. All right, so one more time. It's x2 minus x1 squared plus y2 minus y1 squared. Just go ahead and sing it a couple times, all right? Because it has a little rhythm to it, and you don't want to forget it. So we're going to go ahead and label. Oh, my goodness. x1, y1, x2, y2. All right, just like you do with the slope formula. So x2 is -7 minus -5. No, I'm just messing up here. Minus 0 squared. And y2 is -5 and y1 is 4. All right, so -7 minus 0 squared is 49. -5 minus 4 is -9. So that'd be squared, that'd be 81. All right, so 49 plus 81 is going to be 91, 101, 111, 121, 122. Is that right? Finding that I'm messing up a little bit, so let me just check myself. 130. Wow. Okay. Good thing I have that calculator. Check myself. All right, I don't know. But you know what? It's okay to check your work. Oh my goodness. Now this is the part that's really gonna burst your bubble here. You're gonna be like, I got the right answer. And then it was nitpicky. So you see how it says simplify the radical expression? Yeah. So if you're getting the right answer and you get it wrong, don't sweat it. Because I don't think your geometry teacher is going to make you simplify the radical expression. But I am right now because I know that it does come up. Okay, so what we want to do to simplify a radical is we want to break that number down into two things that multiply to it. And then we want to break those numbers down into two things that multiply to that. And if we got a pair, then that means it would need to be simplified. But see, I got 13, 2, and 5. So that means that this is the final answer. Let me show you one that will get simplified. The square root of 72. The square root of 72 can be broken down into different things, 8 and 9. But I'm going to do 2 and 36 because I know that 36 is 6 times 6. So whenever you break the number down into two things and multiply it to it, and then break down any of those numbers as I did. And if you get any pairs, circle the pair and put one of those numbers on the outside. And anything that did not get circled, like this 2 here, goes on the inside. So we can talk more about that in class, but that's just a brief introduction into simplifying. Okay, the last part is C1, 2, 3, 4, which is won't take that long for you. So the first thing is all about the angle anatomy. So we got the vertex here. This is a side, of course, the points. And how do we name an angle? Okay, so you can name an angle with 3 letters. So sometimes you can use 1 letter. Sometimes. One number. So this could be named as, I think they probably want you to say angle HGI or angle IGH. What was important that the G was in the middle. You have to put the vertex in the middle. If it's the only angle in the picture with that vertex, then you could also write angle G. I don't know if it'll take that in the IXL, but it would be fine if you wrote that in your notes. Angle G, this is angle G. Okay. The other way, the last way, is if you see a number, not a degree measure, but a number inside the angle, then you could also call it by that number. So 3 ways to name an angle. By 3 letters, with the middle letter being the vertex, 1 letter if it's the vertex, and then the only angle with that vertex, or a number if you see a number. Okay, last thing, complementary and supplementary angles. So complementary, two angles that add to 90. So I always like to make a right angle or right angle like this, right? And then look, it quickly can become a C for complementary. Right angle, C, right angle, C. That's how you can remember that. And then the second one is supplementary. Two angles that add to 180. And now, when I was a kid, I was really cool. And, we used to talk to each other in this special way. We used to say, "What's up?" Right? And we wouldn't just say it. We would like, "What's up?" You know, we thought that we were the coolest kids in the school. But the reason that we did that was because when you make a straight line, we should know by now that the straight line measure is 180, side to side. All right. And so when you go, "What's up?" and you make a straight line, you're reminding yourself of that. And you're also saying the first four letters in supplementary. All right. And so supplementary is two angles that add to a straight line. What's up? All right. So what angle is complementary to BGC? So here's BGC. And let's just find the complementary angle. So they have to be two angles that add to 90. We did talk about that right angle box is 90 degrees. And that means this is 90 degrees as well. So we can talk about this angle and BGC are complementary because together they make a right angle. So I would say CGB. So doing this assignment will first help you practice naming your angles, and second, identify complementary and supplementary. Okay, last one. So the measure of an angle is 8 times the measure of its complement. 8x, its complement must be x. So 8x plus x equals 90 because complement means 90. So 9x equals 90, x equals 10. So one of the angles is 10, and then 8 times 10 is 80. So one of the angles is 80. All right, guys, so do your best, and we'll get started on Tuesday.